Okay. Example 2, expectation and a binomial distribution. Okay, Kathy's family moves to an area where they have 7-digit phone numbers. The first 3 digits of all phone numbers are the same. So the first 3 digits aren't going to change. We don't have to worry about those. And the last 4 numbers are equally likely. So we're talking from between 0 and 9. Okay? If Kathy's favorite numbers are 1, 3, 7, and 8, calculate the probability distribution for the number of Kathy's favorite digits in her new telephone number. Okay? Not including the first 3, of course. Those are fixed and we don't know what they are. So let the random variable x denote the number of Kathy's fave numbers in her phone number. Now, let's make a chart. So she could potentially have 0. None of her favorite numbers. She could potentially have 1, 2, 3, or 4. Let's do this smaller. 2, 3, or 4 of her favorite numbers in her phone number. Now, this is a binomial distribution, okay? So the number of trials is 4 because she has 4 numbers, 1, 2, 3, 4, 4 numbers in like the last 4 digits of her phone number. That's what we're dealing with. And x is going to be the number of successes, okay? Now, probability of a success is 4 out of 10 numbers. And a probability of failure is going to be 6 out of 10 numbers. So let's go 2 out of 5, and let's just reduce to 3 out of 5. Okay? Okay, so this is x is going to change from 0, 1, 2, 3, or 4. Okay, so let's start with the choose function. So we have 4 different digits, and we're going to choose none of them from her favorite numbers. So I'm going to change this into decimals so I can write it smaller. 0.4, and this is 0.6. Now, times 0.4, none of them are a success, and 0.6, 4 of them will be a success. Now, we'll do 4 choose 1. Okay, 0.4, 1 of them is a success, and 0.6, 3 of them are successes. 4 choose 2. And you can see a pattern starting. 0.4, 2 are successes, 0.6, 2 are successes. 4 choose 3. And this one I know is going to be 4 choose 4. Okay, 0.4, 3 are successes, and 0.6, 1 is success. 1 is a success. Okay, 4 choose 4, 0.4 to the 4, 0.6 to the 0. This is beautiful. So this is the probability distribution of the number of Kathy's favorite digits in her new telephone number. Now, if we have to calculate the expected number, it would be very tedious to make another line here and do xpx and then to go on your calculator and actually calculate these. If you hand this in to me, this is completely fine. You don't actually have to calculate it in your calculator. It becomes very tedious and the numbers become very small at times. So we don't have to do that. Instead, we're going to use the expected value formula, which is NP. Now, there are 4 digits. There's a 40% chance that each one of those digits is one of her favorite numbers. Therefore, it's expected that 1.6 of those numbers are going to be from her favorite number. Okay. Last example, example 3. A candy store sells bags of candy, 40% which are red. So Vanessa has 10 candies in her plastic baggie. 10 candies, that's telling you the number of trials. Okay? And now, we have to just determine if P is P as a success is red or is not red. So let's actually read the question. What is the probability that at least 3 of Vanessa's candies are red? So we are in search of red. So 0.4 will be P, and then 1 minus the 0.4 will be Q, which is 0.6. Okay? And for the X, we have to do at least 3. Well, do we want to do 3, 4, 5, 6, 7, 8, 9, and 10, those probabilities, or do we just want to do 0, 1, and 2? Then we can use the indirect method to subtract. Okay, so let's do that one. So let's do 10 choose 0, and this is going to be the probability that 0 are red. Okay, let X denote number of candies that are red. Okay, so 10 choose 0 times the probability of a success is 0.4, and you have 0 successes, 0.6, and you have 10 successes. Okay, now the probability of 1, and we'll do the probability of 2. And these ones we'll actually do in our calculators. So we'll do 10 choose 1 and 10 choose 2. 0.4 to the 1, 0.4 to the 2. Okay, and I'm just showing you how to pattern these. 10, this is going to be a 9, and this is going to be an 8. I'm going to change my color for the actual answers. So we just want to put this into our calculators. 10 choose 0 times 0.4 to the 0 times 0.6 to the 10. 1, 2, 3. Okay, that's what I got for the first one. Now 10 choose 1, 1 to the 1, and then 0.6 to the 9. I get 0.00, 0.04. 0. Okay, and then 10 choose 2, 0.4 to the 2, 0.6 to the 8. I get 0.12. Okay, so 0.12 plus 0.040 plus 0.0060. So I get 0.166 for the probability of 0, 1, and 2. However, that's not what we're looking for. We're looking for 1 minus the probability of 0, 1, and 2. So let's do 1 minus 0.166. And our probability that we're looking for is 0.834. So there's an 83.4% chance probability that at least 3 of Vanessa's candies will be red. Now, if we do the expected number of candies that are red, we'll just do n, which is 10, times p, which is 0.4. So the expected number of candies that are red is actually 4.